it'll tell you that I'm recording. And I usually do that right before I'm about to start talking. Um, and sometimes I just forget. Oh, I see. Okay. So you got 10%, 7.2, and then you multiplied that by 72 divided by 3. Oh, and then you multiplied that by 10. Gotcha. Okay. I like that. I like that. Okay. What you want is a consistent thing where you can feel confident, right? And some of you may not feel confident in your algebra skills. Maybe it's been a bit, but these are fairly simple one-step solutions most of the time. You got to divide both sides by such and such, and then move the decimal. Um, but remember, you actually don't, you're kind of letting your calculator get you to the answer. You guys are allowed to use calculators, right? You're simply doing a translation, and then you're saying, what do I have to do to get X by itself? And it's always the opposite operation. So if we're multiplying, we divide. If we're adding, we subtract. And most of these things are going to be dividing both sides. So you have a method, no matter what numbers I throw at you, right? There's a methodology that can get you to the right answer, and then you can feel confident about that. Now, there may be things that go wrong in that process, and then you want to go back and figure out what went wrong. Oh, this is a percent. I needed to, at the very end, move that decimal over. And then you'll see that pretty much they're all the same, um, just slightly different in their numbers, just slight differences between them. Okay, let's go to the conversions. This is going to be a big one for, I'm going to move this over. Where was my number one? Okay, trying to keep track here. Your written assignment next week, the part one is kind of a preview of that. And it's going to involve a lot of, well, sometimes percentages, there's some percentages involved in there, but a lot of conversions. So this is probably the most important concept. So I want to spend some time with this on you. And you want to make sure you're feeling um, somewhat confident in that. I'm going to give you a methodology that can help you convert anything to anything. And we start off with the idea, or this whole idea is based on the idea that anything times one is always equal to itself. It's the multiplicative identity property. Anything times one is just equal to itself. The idea in conversion is that we want to convert something to express it using different units, right? Inches to feet, or feet to yards, or yards to miles. And so if we keep in mind the idea that we don't want to change its amount, we just want to change the way it's being expressed. This idea is similar to what we use with fractions. Um, for example, you kind of instinctively know that 1/2 is equal to 3/6, right? Completely different numbers, but they represent the same decimal. If we turn them into decimal, they're both 0.5. Right? 0.5 is equal to 0.5. So how is it that we have these two very different looking fractions that really represent the same amount? Well, I'm going to pull in this idea here. I can multiply 1/2 by 3 on top and 3 on bottom. And as long as I multiply the top and the bottom by the same number, notice that this is also a statement of division. 3 divided by 3 is equal to 1. So in a sense, I'm multiplying 1/2 by 1. So because of this property, anything multiplied by 1 is still equal to its original value. I'm allowed to do that and still say that they're equal, right? 1 times 3 is 3, 2 times 3 is 6. So because of this multiplicative identity property, anything multiplied by 1 is still equal to itself. We know that 3/6 has the same inherent value as 1/2. We're going to carry this over into conversions. And I'm going to start with the first one, which was inches to yard. I gave you guys some challenging ones here where there's like 2 steps. Go ahead and send me if you got an answer for 2A. I'll write that one down now. Go ahead and send it to me as a private message in the chat box. If you're not feeling confident, that's okay. Just tell me what you got. I'm not grading you and I'm not judging you. I never do. We want to convert this to yards. Okay, got a couple of you there. Anybody else? Send me your answer. Thank you, Scott, Millie, Emily, Felicia. Okay. Now, if it's a larger measurement, right? Yards, if we had a yardstick here, we'd see there's 36 inches in it. If it's a larger measurement, a larger unit, so we're going from smaller to larger. This is small to large. This number should go down, right? If the unit is bigger, I need fewer of them to equal 3,000 inches. So one thing you want to keep in mind if we're going from small to large, the number itself should get smaller. So if the unit is larger that we're using, I'm going to need fewer of those. And the number that we need for the smaller one would have to be bigger. Okay. That's just a general, like, does this answer make sense type of thinking you want to try to do as you work through these problems. But here's the systematic way. We know that we know a couple things. I know that 1 foot is equal to 12 inches, right? That's a statement of equality. These things may have different numbers, but it's because we're using different units, but they represent the same amount of length. We also know that 3 feet equal 1 yard. So because these things are equal, if I put them in a fractional form, 1 foot over 12 inches, oops, or 12 inches over 1 foot, that these essentially have a value of 1, right? These have a value of 1. We have different numbers there. And so if we're just looking at the numbers, 1/12 and 12 and 1 are not the same value. But with the units there, they do represent the same length, right? That's why we call these unit, well, we call this process unit conversion, but these are, we'll just call these units. And actually, we give a more specific name to these, unit multiplier. Because we use this to convert using this property, that anything times 1 is still equal to itself. So if I had 3,000 inches, I'm going to put this over 1 because I'm going to interact it with a fraction, and anything divided by 1, just like multiplying, is still equal to itself, but it at least gives us the visual of a fraction here. 3,000 inches. If I multiply this by 1 foot over 12 inches, and I picked that one specifically, notice there was 2 ways I could have written that, but I chose this one specifically, and here's why. The inches are in the numerator here, and the inches are in the denominator here. I want to get rid of the inches, and I want to convert this first to feet. So If the inches are in opposite parts of the fraction, they cancel out. And so if I go 3,000 times 1 foot, and I divide that by 12, notice inches are gone now. This tells me 3,000 divided by 12 will convert this into feet. I now have the amount in feet. I'm going to leave that as it is for right now. So 3,000 divided by 12 is now the amount of feet. And that comes out to, I think, an approximate amount. Well, actually, it comes out to an exact amount, 250. So now I've converted it to feet. Deciding which of these two I want to use was really dependent on which unit I was trying to get rid of. And here I wanted to get rid of the inches and be left with feet in the numerator. So we leave the one we want in the numerator, and then the one we want to get rid of in the opposite part of the fraction. If this is in the numerator, we want to make sure that that's in the denominator. So now I have 250 feet. I want to convert this over to yards. So the one we're wanting to convert, let's express it as a fraction by putting it over 1. And then we multiply this by the relationship between feet and yards. Right? I want to convert feet to yards. So I say, okay, well, 3 feet is 1 yard. So that's going to give me a 3 feet over 1 yard, or 1 yard over 3 feet. I can use either one of these. Both have a value of 1 because they represent the same length with different units. But I want to use this one because my feet are in the numerator here, and I put it over 1 so I can clearly see that. And so we choose that second one so that feet will cancel out, and I'm left with 250 over 3 yards. 250 over 3 yards, which is approximately, if it's approximate, you can use a squiggly equal sign there. Oops, 250, yep, it looks like 200. 83.3 feet. Good. That was a two-stepper. Welcome, Joseph. We're just going over some problems right now. Good to have you with us. Somebody else came in just a little bit late. I want to make sure I get you on the list. I think I got everybody. Let's see. Yeah, I have 7, so I got you. Okay. Any questions on any of those steps that I did there in converting? Now, there's going to be a lot of conversions you do on your written assignment too. Do you want to show that work to me on our written assignments that we do every week, which this will be due next Wednesday, so a week from now? You want to really systematically show me how you got to your different answers. I want to see your work. Like, that's the whole point of the written assignment. I want to see you and your thought process kind of working these things out. So more you can show me you doing the steps, the easier it is for me to find you. If you just say, well, I turned this into this number, I can't help you as well and say, oh, here's where you made your mistake. It's a little confusing to me. So the work stuff is where you really want, the written assignment is where you really want to show me your work for this. Any questions that you guys had there? Okay, let's go ahead and move to the next group. I don't know where that came from. Let me find some blank space here. Right, our next one, pull it up. We're going from square feet to square yards. Okay, so let's talk about lengths. And the first thing we were dealing with just inches and yards. When we have a linear measurement, let's just say this is 3 feet. It's also 1 yard. You guys know instinctively that these type of things, feet and yards, you would measure by like getting a measurement tape or a yardstick or something like that, and you would measure it out in a straight line. When we have one thing there, that's a linear measurement. But sometimes we also want to know how much two-dimensional space something takes up, right? Like when we talk about the size of a house, the size of a house generally is given in square feet here in the US. Abroad, it would probably be given in square meters, but it's always in some sort of square. And so if I have a two-dimensional space like a floor, and I want to figure out how big is that floor, what we figure out is how many squares would fit in that floor. How many 1 foot by 1 foot squares fit into this space. And so we call that square footage. Uh, or I'll put square space. Footage is very specific, but square space, because we're doing it in a two-dimensional sense where we want to know this and that and how many squares could fit into it. And you guys probably remember if this was like 12 and this was 20, we would multiply those two things, and that tells me how many squares would fit there. Here, this would be a 12 times 20. We multiply by the two dimensions that are there, giving me 240. And that number came up again. And here, since we're measuring in feet, I would say feet, and then we put the little square there. Or you can write out square feet as well. That's another way that people express that. I like it with the two because it reminds you that it's not just 1 foot, it's actually 240 feet by feet, or feet times feet. 1 foot by 1 foot squares. foot foot times foot gives us foot squared, just like x times x gives us x squared. We can use that kind of square there uh, in our description of what it is we're describing. If we have three-dimensional space, like we want to know how much water fits into our pitcher, we use the idea of cubes. I can draw this. So basically what we find, or how we report or describe it, is by how many 1 foot by 1 foot by 1 foot little cubes fit into my space. 1 foot, 1 foot, 1 foot. So those are cubes. When we say cubic feet, so this is cubic space. And if this was, well, let's just go back. We have the 12 and the 20, and then maybe it had 5 as its depth. Notice that we're describing the dimensions, like these are all 5s, this is the depth. These are all 12s, these are the height. If it's a cube, at least, these are all 20, right? So it's the 3 different uh, uh, dimensions there. It's a three-dimensional object. And so this would be a 12 times 20 times 5. We take all of those dimensions, multiply them. Let's say they're all feet, so that's feet times feet times feet. I get 240 times 5. or 1,200 feet, and then we can put cube. So we do that for three-dimensional objects. This is one dimension. This is two dimension. And this is three dimension. And so you can look at actually the exponent there. If we just have, yard, this is to the first dimension. We just don't usually write the one there. So the exponent tells you the number of dimensions we're talking about. So we do this for measuring the length of something. We do this for measuring how much two-dimensional space we're talking about. And we use the cubics when we're talking about three-dimensional or volume, how much liquid a pitcher can hold or that kind of thing. Okay, so let's specifically go to the problem that we were talking about. Hopefully what we're talking about today, this is kind of the exception. Usually I don't do as much lecturing here. We're mostly just troubleshooting and practicing. A lot of what you will be doing as you're doing the reading and all that is learning this, and then I help you reinforce that when we meet together, right? And we work through problems together. All right, specifically, we had 200 square feet. So I'm going to put 200 feet squared. Oh yeah, and you can send me your answer that you got for this. Remember, Shane? And we want to convert this to square yards. So yards are the two. It's important to put that dimension there. And remember, our relationship here is 1 foot, or sorry, 1 yard equals 3 feet. So my 2 unit multipliers, it's either going to be 1 yard over 3 feet or 3 feet over 1 yard. These both equal 1 because they represent the same two-dimensional or one-dimensional distance. All right. We take the one we're starting with, put it over 1. That's 200 square feet. And I know that the relationship between feet and yard is 3 to 1. I want to get rid of feet, so I'm going to use this one here. I'm going to multiply it by 1 yard, the unit I want it to be in, divided by 3 feet, which is the one I want to get rid of. But notice this is just foot to the 1 power. Feet squared means feet times feet. So 2 units of feet. So this feet is only going to get rid of one of these 2 feet that I have here. This becomes a 1 now if I divide it by 3. So what I need to do is multiply by 2 of these. The second foot will get rid of this remaining measurement of foot that I have here. And notice I'll end up with yard times yard. So 200 divided by 3 times 3 converts this into square yards. We should divide by 3 twice. 3 times 3 is 9. And so that gives us 200 divided by 9, which is 22.2 square yards. And I had yard times yard. So remember that becomes, we treat those units as what they would do if they were numbers or variables. Now, if you go 200 divided by 3 times 3 on your calculator. So let me write it. Let me type. This is what I see on my calculator. I have a TI 83 or 84. If you go 200 divided by 3 times 3 into your calculator, what happens is your calculator is following the order of operations. And with multiplication and division, it does them from left to right. So it'll divide 200 by 3, and then it'll multiply that result that you get by 3. 200 divided by 3, let's see, 200 divided by 3 is 66.6 repeating. And then if you multiply this by 3, you end up back at 200. Because you just divided by 3 and multiply by 3. That's really confusing. The way you want to enter this into your calculator is to put parentheses around this. Parentheses VIP, the operation. So it's saying, do that multiplication by 3 first, and then divide that into 200. If there's more than one operation in a fraction like this, you want to generally put a parenthesis around it as you enter it into your calculator. Yeah, so the right answer, if we round it, is approximately 22.2. Why, let's see, why don't we divide 200 by 3? We do, but we have to divide it by 3 twice. So if you went 200 divided by 3 and then divided by 3 again, that gets us to the 22.2. And the reason we have to do that, the reason why we have to divide it twice is because we have square feet. And so each one of these feet only cancels out one of those two. Square feet means feet times feet. So we have to do it twice to get rid of the square feet and also to put this into square yards. Does that make sense? Yeah, and you can just divide by 9 too. Yeah, yeah. Just in general, when you see this, sometimes you can do those things in your head, like, well, I know what 3 times 3 is, so why not just type 9? But sometimes it's numbers that you don't know in your head. You want your calculator to do it. Just use that parenthesis button on your calculator to prioritize this multiplication before you do the division. Because with multiplication and division, your calculator will do it from left to right. So it'll just do this first. And then if you say times 3, it's going to just multiply that result by 3 and take you back to 200. Well, you know that's not right. Okay, and then the last one was in cubic, so that's a 3-dimensional deal. We have 3,500, or sorry, not 3,500, 35,000 cubic inches. So I'm gonna write inches cubed. Use that 3 there. It's a great, using the 3 instead of writing out cube is gonna remind you that there's 3 operations that need to occur. Because 3-dimensional space is a length times width times depth measurement. And we're converting this to cubic yards. Now, you could do this in 1 step. I'm going to show you in 2 steps, because generally this is what people remember. They're like 1 inch, or I'm sorry, 1 yard is equal to 3 feet. And then remember that 12 inches is equal to 1 foot. Like that's that I put 3, 1 foot, right? That's generally what we remember. So if that's what you remember, then you can do it in 2 steps. You can also just figure out what is the relationship between 1 yard and inches. Question mark. How many inches are in 1 yard? Well, we know it's 3 feet, so that would be 36 inches, right? That's, in this case, since we're doing with cubic, is probably going to be the better unit for us to use. Just sort of the direct, right? Just be confident about what that relationship is. If we know that there are 36 inches in 1 yard, here's my unit multiplier. We can use 1 yard over 36 inches or 36 inches over 1 yard. You don't have to even think. Notice this is a methodology here about, do I multiply? Do I divide? Using the unit multiplier, the relationship here, where you have an equality, and changing that to a unit multiplier is going to tell you what you have to do, because I want to get rid of inches, right? So in this one, if I want to get rid of inches, the inches here are on top of the fraction. So I want to use the one where the inches are on the denominator of the fraction. Okay. You put square yards. Yep. So then that's gonna, you got to do that one more time. You're going to do one more division there. I want yards, so that goes on top. 1 yard over 36 inches. 1 yard over 36 inches. I got to do this 3 times. Because there are 3 inches there. So to get rid of cubic inches, I need 3 linear units of inches down there. So I see that to get this, I need to go 35,000 divided by 36 times itself 3 times. So if I was typing this into my calculator, I would want to put that multiplication into parentheses. So I'll go 35,000 divided by, here's where you probably don't have that outcome in your head, right? So divided by parentheses, 36 times 36 times 36. Parentheses prioritize that before the other. And we always, in a fraction, generally, if there's more than one operation going on within the fraction, we want to put parentheses around it. And so that comes out to 0.750. So I'm just going to round it to that. That's an approximation. So it's about 0.75 cubic yards. Yard times yard times yard. I know it's a little more work to write all these out, but practice doing this. When you practice doing it for the more easier ones, it's going to be easier for you to do it for the more complicated ones. You're going to want to be able to go several steps in some of these. You're going to want to know area. You're going to want to know depth. So you're going to want to know volume. So 3 dimensions on your written assignment next week. And there's some exercises that are going to help you do this. So this is actually ends up being, well, it's 0.75. A yard is pretty long. So about 3/4 of a yard, three ways. So there you go. Any questions on what I did there? Loving the feedback you guys are giving me as we're going through this. You know, the best way to keep yourself motivated is to feed that area of curiosity as you go through this. You know, want to know the answers or want to know the whys behind the answers that we get. Like, why does that work? And so that's how I try to show you as we go through these, is kind of to get those whys answered so it makes sense to you. If something makes sense to you, it's way less like uh, intimidating, right? You're like, oh yeah, well that makes perfect sense. But when you're learning something new, it doesn't usually always make sense at the beginning. Okay, let's go to number 3. Here's a longer problem, and here's where problem solving really comes into play, at least one aspect of it, where you're given this long sentence. We got to kind of break it out a little bit, right? So employees in 2012 paid 4% of their gross wages towards Social Security, while employers paid another 6.2%. How much would be paid towards Social Security for someone earning 60,000 a year? How much will there be after taxes are paid by the individual? Okay, so there's 2 parts to these questions, isn't there? There's 2 question marks there. Number 1, how much will be paid towards Social Security for somebody earning 60,000 a year? And then, so how much paid towards Social Security for somebody earning 60,000 a year? Um, that sounds like a total, right? The word total isn't in there, but it just says how much is going to be given to the government for this employee uh, for their Social Security. So part of it is going to be paid by the individual, and then the other is paid by the employer. So they don't take that out of the individual's check, in other words, but it is based on how much they're making. So I can figure out those individually. One way to do it was, well, for this one, is to do it individually and then add that total together. But then we want to, the second part is telling me, uh, is asking, sorry, how much will there be after the taxes were paid by the individual? So how much, in other words, after the individual pays their taxes, how much are they going to have left, right? And that is done as a portion, right? They're only 4.2%. The employer's paying 6.4. Now, for the first part, how much total is paid, we could just add those two percentages together and take that percent of 60,000. In other words, I can take, so I'm going to write a couple things down here. I don't want to rewrite the whole question, but 4.2 individual Social Security, 6.2 is employer Social Security. So I'm just kind of writing it down so I can know, just putting down the information there. And then we also have another bit of information is 60,000 is the salary of the individual. And the first question is asking total taxes paid. I'm translating it, right? Total taxes paid to the government. Well, if we add those together, that's 10.4%, right? 6.2 plus 6.2, sorry, 4.2 plus 6.2. That comes out to 10.4%. So if I wanted to answer that, this is one way I could do it. I could figure out what 10.4% of $60,000 would be, right? And the of tells me that to solve this, I am going to multiply. And so getting rid of the decimal, I'm going to move this back. We're going to take 0.104. We're going to multiply it by 60,000. And that gives me $6,240 paid total in Social Security for that individual. Part of that is paid by the individual, and the part of that was contributed by the employer. Now, the second part says how much will the individual have after the taxes are paid? Well, the individual is only paying this amount. So if I go and I put that into a decimal, we have 4.2% of 60,000. This is what we want to find. I want to, percentages are always based on something, of something, right? So 4.2, if I want to know what the amount is, I got to say, well, 4.2 of what? Well, it's based on their salary. So 4.2 of 60,000. Putting this as a decimal, this is 0.042, right? Because we move it back 2 spots. So we go bam, bam. There's an empty spot there that we fill in with the 0 times 60,000. This will tell me how much the individual paid. So it looks like of that 6,240, 2,520 was paid by the individual. And so how much did they have after taxes? Well, if these are the taxes we want to subtract. So we're going to go 60,000 minus this. Oops. That gives me 57,480. Of course, that's before income taxes. So there we go. This is how much, and it's dollars kept by the individual. Make sure you're answering the question not just with the number, but with a little explanation of what that number represents. It's dollars. So I want to put that dollar sign in there, which of course on the WAMAP questions, you're not going to do because you don't usually put those symbols in there. Just put the number. But you want to know what it is that this number represents. So make it clear for yourself what this is. This is dollars. I should put that there too. Now can anyone think of a different way that I could have found this number, 50,480? So it wasn't 2 steps, so I didn't have to subtract at the end. Anybody do it differently? If not, that's okay too. I was gonna just throw this in here. Remember, if it was 100%, 100% of 60,000, what does 100 represent in terms of decimal? Well, that's 1. 100% of 60,000 is 60,000. That's an important concept to remember. 100 represents 1. 100% of 60,000 is 60,000. If you had to pay 100% tax, you'd be just handing over your check right to the government. You'd be paying 100% of it, 60,000. Why do I say that? Well, this amount is being taken out in taxes, right? So in other words, I'm taking 100% and I'm taking away 4.2%. There's a decimal here, so we're lining those up. So if I do that, I get 94.8. 100 minus 4.2. I do that right? Yeah. Or 95.8, sorry, not 94.8. So if I wanted to just like taking this away, this represents how much they're going to keep of their money. So another way to do this is to take 60, find out what 95.8% of 60,000 is. So multiply 60,000 by 0.958. And that calculates immediately without having to subtract how much they're going to keep. And this should give us the same thing, $57,480. So that's another way you could have done that. If you're taking this away, this is the percent you have left. And so we're just kind of rewording it, kind of thinking it from a different perspective. And the idea here is like, let's say we're finding 40% of, let's just pick a number, 200. Well, 40% of 200 is 80. If I took 60% of 200, notice that 60 plus 40 is 100. That gives me 120. Notice that these two both add up to 200. So the percentages can be reconfigured. If you know you're going to have to, like it's a tax, you can subtract it out or something like that. You can always subtract that amount from 100 and you'll figure out what the price is. If something was 30% off, right? Like a piece of clothing, 30% off. Yay, exclamation points, exclamation points. 30% off sale. Uh, if you want to figure out the price, you can just multiply it by 70%. If the 30% is representing the discount, 70% will represent the new price that you're paying. As long as they both add up to 100. That makes sense? Okay. So some of you are still getting used to Wallmap. I'm going to switch off here from this screen and go back to my computer screen. All right. Good to see all of you out there. As we went over, there's I'm going to point this out and thank you. I can't remember who it was that alerted me to the fact that the link wasn't working when I first posted it. So I should have today's recording posted. Remember, I did start a little bit late there, but we started with our 15-minute check. So if you came in late, normally there's the problems that we're working out there. The class spent the first 15, 20 minutes working through those. And we're going to do the same thing when we meet again on Monday. Every time we meet, there'll be a 15-minute check. It usually takes us about 20 minutes. Usually doesn't take us this long to go over it. But when we first met, which was Monday, I have it recorded, and I always post the recordings of our class sessions. So if you were not here Monday, you should go back and, if you haven't already, watched the class recording. At the top here is an introduction to Wallmap. I keep this here as just a reference tool to remind you of what you want to be doing throughout the week. Basically, if you do the syllabus and what we talk, watch that video, we talk about how you want to kind of be looking toward next week. After today, which is Wednesday, we're usually starting on the next week topic. This is our first week, so we kind of did an introduction here, and then I gotta work through some problems with you. So as you're looking toward Monday, which is when our first exercises come due, they'll be due an hour after our class sessions end. This is what you want to be working on from now until Monday, is these exercises. Once you've completed those, then you want to start working on the written assignment, which comes due, and then the quiz. I also have a prepare for so do the quiz last. That's going to be timed. The first one is an hour and a half, gives you a long time, and you get 2 chances at it. So if you don't do so well the first time, you do have a chance to take it again. The prepare for final assignment is usually a bunch of review problems from the previous weeks. So I combine maybe week 2 and week 3 when we're in week 4 and week 1. But so our first one, for the final exam, which will be online, you'll want to have 1 page of notes, 1 page of condensed notes that you can use for that final. And so on this first week, I just have you submit those notes in here so I can take a look at them. You can have examples with those. Some of the main concepts as you go through the reading, I link the reading here, and the videos are linked here. When you click on the calendar, those links appear below the calendar. So you can go directly to those assignments from these links in the calendar by clicking on the calendar dates, or you can go through and see all those links in here. I have the required reading here, which takes you right to the book. Read through that, take notes on the most important concepts, points there that they have. Then you have a selection of videos. These are worked out examples from the book, but also there's some little lessons here. So you can use a combination of the book and the videos to kind of get through the concepts. Then you want to start working on the exercises. This comes due Friday. In this case, we have actually a part 1 for the written assignment. This shouldn't take you too long. It's really just, I want you to give me an educated guess. And let me take you into the problem. So a neighbor of mine, their lawn isn't looking that great. So we get this view of the lawn, top view, probably from Google. And we're going to try to remove all the old grass and put in a 4-inch layer of topsoil. Put in sprinklers, reseed, blah, 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 blah. He wants to figure out how much soil he needs to purchase. So here you're going to kind of look at, notice that we have a scale here. This tells you from this distance here, this would be 20 feet. If you want to do it in meters, I wouldn't recommend that, but that would be 10 meters. So 20 feet or meters, I recommend keeping it in feet. Give an estimate of how much soil you think you'll need. And here, this is just an educated guess. And then you want to think about what other things would I need to know? Because there's more stuff that I'm not describing here. Because he needs to decide whether he wants to get that dirt delivered or whether he should use his truck to do it himself. So you want to get an idea of how many loads do you think you would need? That's kind of an educated guess. And then what other information do you need? Because you definitely need some more information here in order to make that decision. So here, what I want you to do is to just think through what are some other important pieces of information that would be important for me to decide that which one is cheaper, whether he has it delivered or whether he gets it himself. All right, and that's going to come due Friday. Part 2, you're actually going to work through that. For you guys who are new, watch that video. You always communicate with me through the messages here. That's the best way. I do check Canvas and I do check my email, but I check this the most often. So that's the quickest way to communicate with me. Any general questions that you all have for me before I let you go here? You can either type it in the chat box or you can also turn on your mics. You have the ability to do that by clicking in the participant or just go to your mute button. I will.
So yeah. My question is, I did the quiz on Monday, but I can't tell if it was recorded or not.
Okay.
Because it says like use late pass. But I know I already did it.
You did the syllabus quiz, is that right?
That's right. Yep.
Yeah. Okay. You used the late pass, so you did it yesterday?
No, I did it Monday.
Oh, then what? Okay, so you don't need to use.
I can't tell whether or not it recorded or not. Because there's still a green dot next to it. And it says use late pass. So I don't know if that stays up there or.
Oh, because you can take it twice. I think it's the settings, maybe. But
okay.
Just note that the icons on here, it'd be nice that once you completed something, they become not colored anymore. But basically, that doesn't happen. Once you've completed it, the way you can tell and see what you got on it is by going into the gradebook icon on the left here.
Okay.
And if you click on that, it'll show you all your assignments. So you just want to find that particular assignment. It'll have your score and your percentage next to it. And I would go into my gradebook, but can you see it? Okay, good. Yep. So your gradebook. Now, when it says past due, that's the percent you want to think. The past due total at the bottom there tells you all the assignments that have come due so far. This is how you've done on the ones that we've completed so far. The other column is like the percent that you've done of everything that we're doing. So that eventually those two numbers by the very end become the same. But until then, it's really just giving you a percent of the assignments that you've done out of everything. So it's really not helpful. Yeah. So always look at the past due. There are some of the written assignments, keep in mind, I have to grade those manually. I don't think there have been any so far. If any of you were not around or did not get to do these introductory assignments that are in gray, send me a message and I will move those for you so you can get those completed today. Stick around after and I can do that. So for those of you who were here Monday, you don't have any other questions, if feel free to, I'm going to complete our class unless there's any other questions from anyone else. If you have personal questions, you can stick around and we can tackle those. I should have asked before I dismissed.
Yeah.
Were there any further questions?
Yes, I have a question.
Emily.
Yes, can you hear me good?
I can. Yep.
Awesome. I had a question. So I know that if we don't show up to this live
Session.
class, we don't really get points for it. I am starting as a tutor in the Fort Steilacoom campus and
Oh.
have DRL training scheduled around from the 8th to the 11th, and it had just happened to be at the time of this class. So I was just gonna, I was wondering if that's gonna affect my grade at all if I'm not able to make it because I'm in that training.
Well, there's three ways that you can earn extra credit. One is, as we talked about on Monday, any unused late passes you don't use will count toward extra credit. So if you don't use any of your late passes, you're going to get some extra credit from those. But use them if you need to. Okay, you'll get
Yeah.
a lot more from that. But don't try to save your late passes and not do an assignment. That's not a good strategy. The second thing is attendance when we're meeting live. So I give you some points for that. And then the third way is the 15-minute checks. Now, if you're not here, I will be recording that, and I'm going to post the 15-minute check document in there as well because I started the recording late. But if you're not here live, you can go back and watch the recordings and still get those 15-minute checkpoints. So the only point that you will miss is just the attendant part for those 2 days. But all that is extra credit, right? So it's, when you ask, does it hurt my grade? It really is not hurting your grade. You're just missing out on some extra credit there.
Okay. Okay. Yeah, that sounds fine.
Yeah.
Alrighty. Thank you so much.
You're welcome. Anybody else? All right. If not, have a great rest of the week. Get into that reading first and then start working on the things coming due Monday and Wednesday of next week. Have a great weekend, everyone. I'll be sticking around a little bit here afterwards if you have questions as well. Joseph, did you have some questions for me?
Yes, can you hear me?
Yes.
Hello. Yeah, I was one of the people that didn't show up on Monday because I showed up in person.
Oh, okay.
So
great. But you're signed into the system, right? Because I
yes,
saw that you enrolled on Monday morning. So have you been able to watch the class session video yet?
yes, I have.
Oh, okay, great. And so you got most of the information. That's good. And we're always going to be meeting online. So there isn't going to be a time where we meet on campus. So it's not, as long as you are like, are you feeling pretty good? Like you understand kind of the process and of what we're doing and what you need to be doing?
I think so. You also said that if we missed it, the autobiography and the
Oh yeah.
profile picture, would I be able to do
Yep.
that still?
Yep. Let me go to your, let's see. Absolutely. So when you look at the calendar, those are the due dates. So
Yeah.
one of the tricky things that you got to get used to is kind of looking at going, oh, okay, Monday, this is coming due. So I got to start the readings and I got to watch the videos and then start working on those exercises. And then there's something coming due Friday too. But when we're starting out here, it looks like you did the syllabus and quiz assignment.
Yes.
So I don't need to do that. Let's see, what else is there? There's so it's just the autobiography and the profile pic, I think. So I'm gonna put these out to profile pic. Just today at midnight. Are you able to get to that today?
Yes, I will do that today.
Okay. I'm gonna put this PM. So I gotta do this twice. The profile pic, you just have to, they give you instructions about how to attach a profile picture to your account in here.
Okay.
And then just reply to my post. And then you're done.
Okay.
It's super easy. Well, good to see you here in person.
Thank you.
Yeah, if you have any questions.
Sorry about all the confusion I had.
It's all right. You weren't the only one. We have 10 people, and so there's still 3 who haven't shown up at all and aren't even registered. So you're doing good. You got registered in there the first day. It was a little confusing, and as much as I try to tell people through Canvas and emails, a lot of times they just don't. You've got other things and you miss it, so it's no big deal. Good to see you here today.
Okay. Well, thank you. I appreciate it.
You're welcome. If you have any questions or need help on anything, always just send me a message. It's best to do it in Walmart because I check that several times a day versus like my email and the Canvas messages. But
Okay.
yeah.
Okay. Well, thank you. Nice to meet you.
Nice to meet you too. Look forward to working with you.
Yep. Have a good one.
Okay. Bye.
All right. Bye.